Hi, I'm Ramesh Ranjan, the editor of humanengineers.com, a popular HR blog and website. This platform tries to bring in business and thought leaders to address issues regarding people side of business. Our aim is to promote and encourage discussions around topics that will help organizations make the most of these people. Welcome to this HR talk show, People at Work. Our world today is often disrupted and impacted by the digital transformation that's happening all over us. Every walk of our life is now being impacted by digital transformation. By now we are all familiar with Alexa, OK Google, Siri, Cortana, Google navigation systems, autonomous cars. At the core of all this is artificial intelligence. But what is artificial intelligence? Way back in 1950, Turing, known as the father of computer, asked this question: can the computers think? That started the journey of artificial intelligence. Artificial intelligence has been popularized through science fictions, Hollywood movies, and has made it come real and closer to all of us. What exactly is artificial intelligence? There is so much jargons around that: machine learning, deep learning, virtual reality, algorithms, speech recognition, text recognition, and etc. To understand what exactly artificial intelligence is, and to understand it from a layman's language, we have with us Harish Shetty, who is the Group Manager, Advanced Analytics at IBM, to help us unclutter about artificial intelligence. Harish has a wealth of experience, about 20 years of experience in the IT industry, including 6 years of experience in data science, analytics, and artificial intelligence. He has a wide array of knowledge in machine learning, NLP, text recognition, autonomous vehicles, and other areas of computer science. Prior to IBM, he was working as a data scientist at PepsiCo. He's also worked with companies like Fidelity Investments, Symphony, and Encora. We are very privileged and glad to have Harish with us, trying to help us unclutter and simplify what artificial intelligence is. Over to you, Harish, to help us understand and simplify artificial intelligence.
Thanks a lot, Ranjan.
Thank you.
And thanks for giving this opportunity and inviting me for this talk show. So, as you mentioned, I have around 8 years of experience in AI and 4 years in IBM, and prior to that I had my own startup where actually that is where I got introduced to AI and machine learning. So one of the questions everyone asks is, what is AI and what is artificial intelligence? You Google, you find a lot of definition, like AI is this, AI is that. So let me simplify it, right? Artificial intelligence is machine doing the cognitive task which humans can do. For example, let's say I give you a picture. In the picture, there is one tree, there is one dog, and let's say there is one baby. And you can straight away recognize them, right? And you can do this task consistently well. So, as a rule of thumb, if there is any task a human can do pretty accurately, I think we can train machines to do this task, provided there is sufficient data. And that's the catch here. Now, to build AI system, what is required? As I mentioned earlier, we require data, we require coding, that is computer science skills, math skills, which includes machine learning algorithms, the basic statistical algos, and of course, one of the very important thing which people miss out is domain knowledge, right? All these components together helps us to build a AI system. Some of the use cases, what I can say is, like you swipe your card, right? There will be a fraud detection algorithm running in the back end, which says whether there is a potential fraudulent transaction here. You log into any e-commerce site like Amazon or Flipkart, there will be recommendation. They recommend based on your browsing history, previous shopping history, and all those things, right? And then you have this computer vision technologies like object detection, face detection. Language translation is one of a very useful use case, and also search engines. These are all some of the AI use cases. Now, there are certain components I told which build AI system, that is data, computer science, maths, domain. All these things are not new, right? These are there since decades. Why in recent years we hear about this more, right? The reason is availability of computing power, cheap computing power, and exponential growth in data. The combination of these two has made AI solutions more reliable. Like in Indian mythology, we try to explain concepts by storytelling. That is the approach which I am going to take. I'll make use of some made up use cases to make you understand different jargons. I'll not try to be too technical. At the same time, I don't want to be too high level also, where after this 30-minute session there is no value added.
Right.
One of the questions which always pops out is, what is the difference between a rule-based system and AI-based system? As an end user, you will never know what is powering your app, right? Is it a rule-based system or is it an AI-based system? It's better we know something about this. For example, especially in the domain which I worked previously, that is stock market equity domain, there are a lot of mis-selling happening. They come up with the product and say, look, we recommend which company you can invest, and our AI engine goes through all the previous data and recommends and stock to invest where you can make hell lot of money. There might be a little AI there, but most of the time there might be just somebody coding a rule-based engine. So it's better we know what's the difference between these two. Here I might get a little technical, but I think it's very important for us to understand what is the difference between these two. So what is a rule-based system? You have an input, you work on the input and you give the output. There's a logic you apply on this input. For example, let's say I traveled 5 miles and I want to know in kilometers what's the distance I traveled, right? So I know 1 mile is equal to 1.6 kilometers. So I multiply 5 into 1.6, whatever answer I get, that is the this thing value in kilometers, right? This is rule-based system. You already know what is the constant in which I am multiplying. Now, a AI-based system, right, would not know this. It will not know the rules. So what we do is, we don't tell the AI system what is the logic, how we convert the input to the output. But what we're going to feed them is data. Like we will provide the input data, in this case the miles, and we'll give the output data. In this case it's the kilometers. The AI algorithms or the machine learning model or statistical model which we build learns from this data, it iterates through this data, and it knows what this logic is, that we have to multiply by 1.6. So very simple algorithms like what I'm showing right now here is, we call it linear regression. It just runs through this data and it try to understand the logic. There are more complex algorithms like the neural network algorithms or reinforcement learning. They go through the data again and again and they learn. So, but the high level, this is what happens. You provide the clean data, the model learns it and it gives the output. And then when we make this product live, you give the unseen data, it gives the prediction. That is how AI based system works. I have taken a very simple example, but I think this will help to understand the difference between rule based system and AI based system. Now if you ask me, for this particular use case, will I use a AI based system? No, this is a overkill, because I already know what is the logic for converting input to output. Here I would actually use a rule based system. So earlier, right, the fraud detection systems were mostly rule based. Now the AI has taken over, and many of these fraud detection systems are AI based. And recommendation engine, which I just mentioned, like when you log into Amazon website, we have a lot of product which is recommended. These are all AI based systems. So the technique which I just explained, just to add some jargon, is called supervised learning, because we are giving the input data and we are asking the model to learn, and how we are supervising it by giving the output data. So this kind of learning is called supervised learning. And there are other techniques called unsupervised, where generally in marketing they use, you have data customer segmentation, right? A high value customer, low value customer, it might be anything. Those kind of segmentation we do, those kind of algorithms are called unsupervised. I want to explain different challenges we face when we actually try to build a AI based system. And also during this storytelling, I want to explain various concepts and jargons. Let's say I have one fantastic startup idea, right? So I want to build an app which is a location based app, and you point to a location and it will tell the real estate price of that particular location, right? So this is my startup idea. Now I assemble a fantastic team, like Avenger team. They start building the product. After some days, a data scientist in your team comes to you and says, look, if you want me to build this model, I need data, right? Please get me the data. So you go around, either you try to generate this data. In this case, you may have to get the data from external source. So you get a vendor from whom you get this data. So before using this data, there are a lot of things related to ethics, data protection you need to understand. For example, is the vendor authorized to sell this data? Is the data reliable? So these are some of the questions you need to ask. Let's say in your case, you got the data from government itself, government of Karnataka. They have all the registration transaction details of sub-register office across Karnataka, and they've shared this data with you. So good, this data is from a reliable source. Still, you need to have a framework, data protection framework. The reason is, there are a lot of user related data, like there might be PAN card, Aadhaar detail, might be gender, all those things, right? These are all user related data, personal data, and these needs to be protected. So you need to have a framework within your company which can handle these scenarios. It's not that you can't use it. If you are using it, do you have the required permissions to use this? So this is a very important aspect, because later on you shouldn't face any problem due to this, right? Okay, done. We took care of the data. We have all the required permission. Now our team worked for a couple of months. They came up with a fantastic app which passes all the checks. When I say passes all the check, it has a very good UI. You point to the location in the map, it suggests the real estate price in that particular location within a fraction of a second. That's what we want, right? Very quick user experience, and we're extremely happy how it's happened. Now we go live, right? So the end users, in this case might be real estate agents or real estate companies, they download this app and they start using this. So what we see is, our app started recommending price which is lower than the prevailing marketing price, and this is happening at a consistent basis. So even though technically we have a perfect product with amazing speed, very good UI, but still it's not doing the work which is supposed to do, that is recommending correct price. Now we have bunch of unsatisfied users, they uninstall this app, right? Now we have brainstorming sessions. Are we doing right? Do we have a correct team to tackle this data? In AI, we sometimes hit the ceiling. Beyond that, it's very difficult to improve the accuracy of the model with the current technology and algorithms. So all these things, questions pops up. Now what to do? So what we did was, let's say this particular company, they hired a domain expert, a real estate domain expert. Now they do brainstorming session, and he says one word: garbage in, garbage out. So one of the things what we know is how our property is getting registered, right? I mean, usually the deal value in the register, the deed, sale deed is always lower than the prevailing market price. And our model, what it has done is it's taken that as the data and it has predicted, and definitely there would be our prediction will be lower than the prevailing market value. Why this is done? We all know the reason, right? So we identified the problem. How did you identify this problem? Because of the domain experts, right? I mean, this is something which I wanted to say, the importance of a domain expert. Not only in our solution or model validation, but also during the building process. We do something called feature engineering, like we generate features from which the model is built. The better the feature, the better the model. So there also the domain expert plays a big role, right? Now we go back, we calculate the uplift factor for this, and then we modify the app and we push the update, right? What happened to this app, I don't know, but what I know is we need clean data. That's very important. And the technology, 10-15 years back, right? I mean, you have a data scientist. He might be a domain expert. He'll have some he'll learned R or some SAS or something like that, where he develops the model standalone and he gives it. Things are changing. I feel for data scientist or anybody like who's in the tech field, it's always better to be a good coder. The reason is you might have an idea, right? I mean, let's say as a guy who build model, I have an idea. I want to just try it. I just go switch on my computer, just try a dirty model. Okay, done. So I can't rely on my team or somebody else to do all this small task, right? And also, things have become very complicated, right? I mean, now everything is moved to cloud. We need to talk with different pieces of the software we call as microservices, and this has to be integrated. For this, little bit of coding experience is very much required. Most of these teams, we don't have like 20-30 member team doing only the data science work, right? I mean, generally at the core there might be 3-4 member, and others would be different set of people. So what I want to say is, along with data, knowing the technology aspect has become very important in today's world. And one of the thing which was even before very important and even now it's very important is domain knowledge. But that is a piece which helps you, as I mentioned earlier, in model validation, which is very much important. So domain experience, the knowledge is very important, right? Until now, I was talking about scenarios where you have built an AI solution, and when it actually is in the production, what we do is we send this to the server. The server does some calculations or runs a model and gives the answer, and that's what happens. So this is server-based setup. Now, due to various reasons, let's say I have a factory, I have a manufacturing setup. I work generally I manufacture defense-related items, which is highly confidential, right? and I can't send my data outside my premise, outside my factory. But at the same time, I want to use this latest exponential technologies like AI, all those things, so that I build a fantastic product faster. So in this case, security becomes a big issue. There might be other aspects in factories, like there are a lot of sensor data that keeps generating. I want to make use of this sensor data. So I may not have the bandwidth. As I mentioned earlier, the security framework doesn't allow me to send the data to a server outside my factory. In such case, what we have is edge AI. So it's like we are getting these AI models where near the source of data generation, like factory. One of the manufacturing companies have adopted this edge AI pretty well. So one of the use cases, safety of workers, right? So on the shop floor, the workers need to wear helmet, right? And we can't keep checking each and every person, right? So if you have a AI technology which can raise alert when somebody is not following this rule, even the mask nowadays, and predictive maintenance, like we have a lot of sensor data, and when anomaly is detected, we can just raise an alert. Agriculture is another field where this edge AI would play a big role. So most of this agriculture field, right, they are in place where we don't have internet connections, right? So we might have to have a solution where let's say you have a mobile, take a photo, and it tells the health of the crop. So even our mobile device, right, it's an one of the edge AI, because we are not aware, but a lot of AI work keeps happening there, and of late our mobile device has a lot of computing power, right? One of the best use case what I can think about when I talk about edge AI is self-driving car. Here we don't have the luxury of sending the data to the server and getting the response back. Okay, slow down the car, apply the brake, change the lane, right? So all the computations would be happening on the computer which is inside the car. While explaining, or when I'm talking about the self-driving car, I also want to emphasize the fact that how various technologies, how various domains work together to build this self-driving car solutions. We started our presentation with a very simple linear regression model. Now I'm going to the other extreme case of a very complicated self-driving car scenario. One of the main component in a self-driving car is computer vision. For example, when you're traveling, you look at the traffic light and you want to know whether it's red, green or yellow. Lane detection. Then you have object detection, whether there is a car in front of you, there is a pedestrian, all those things. These are all computer vision related technologies, and AI plays a big role here. Then you have sensor fusion. This is basically to do with signal processing. You have radar and lidar. You get a lot of the sensor data. Using this, you try to understand what are the objects around you, right? So this is basically the we call it Kalman filter, signal processing. So in that domain. Then the third is we call localization. You need to know where the car is, right? You might ask, okay, I'll use GPS, but GPS is accurate to level of 10 meters, and that is not good enough, right? You might have a person next to you in one object 2 meters away, then you might bang this thing. So understanding where you are, location of the car, that's we call localization. You have all these pieces together. Now you are traveling, and let's say you have calculated and you feel 50 miles per hour is ideal speed on which I will travel on this highway, and this is within the legal limit. Now there is a car in front of you which is traveling at 30 miles per hour, which is slow. So what you want to do? You want to change the lane. So already you know there is a car there. Using the sensor, we will try to know is there a car next to you or behind you, and then you change the lane. That's what as a human you do, right? And this is what you expect the self-driving car to do. So what they do is they do trajectory calculations. Now everything is done, trajectory calculation is done. Now I have to steer the car there. So this is where the control comes, where you control the car to follow the trajectory which you have planned. As you see, when we say self-driving car, we think, okay, this is one AI solution. There are a lot of other pieces also. There is signal processing, there is computer vision, localization, path planning, control, all together, right? This is what a AI solution does, right? It's, 10 years back, do you ever thought that, this is possible? So, as I mentioned earlier, the rule of thumb is, if a human can do a task accurately, we can train AI model to do it, provided we have sufficient data. And there are, one of the domain which I came from, in the startup which I work, that is stock market domain, right? The market is very, you have noisy data. As a human, it's very difficult for us to predict whether the market will go up or down, right? So one of the things which I also try to do initially, where I failed miserably first year, is I try to replicate that. I wanted to build a AI model which predicts whether the market will go up and down. It didn't work, for me. So, but there are other things which you can do. There's huge data. You can mine those data. You can find some pattern where where you can consistently make money, and provided that the pattern is happening, good number of times. Let's say you find a pattern which happened 10 times in the last 10 years, which is not good enough for me. But which happens, find a pattern which keeps happening more frequently. That is where, it's more useful for me. Also, again, I want to emphasize the domain knowledge here, right? Initially, how I got into this, AI is, I never wanted to be a data scientist. I am a solutioner at heart. I have a problem, I want to solve it, and if for solving this problem, if I have to learn AI, I will learn it. If I need to use a rule-based engine, I'll use a rule-based engine. If I don't need coding at all, it's okay. I will use something else. So always I look from the solution perspective. And when I was trying to solve my problem in my startup, I thought, because I was creating a lot of rules, right? Manual rules, and it keeps changing. So that is when I went to this, machine learning kind of concepts. So as a solution for the problem in hand. But very soon I understood predicting market is not so easy. But there are certain things which help me. One is what we call as regime detection, right? So I'm okay. I can't predict whether the market goes up or down, but I can, if I know what kind of regime right now I am in, that might help me, because I might have hundreds of strategies which may not work always, but in certain market conditions these strategies might work, right? These strategies might be simple rule-based strategies, right? But by doing this regime detection and zeroing on to those strategies which actually would work, it helped me. So what I want to say here is, it's the domain knowledge which helped. Even though there's a technical piece there, but the domain knowledge helped me to implement this. Then again, the risk management also comes here. So during this presentation, right, I talked about various jargons like data security, ethics, domains, programming, hardware, cloud, edge, big data. So all those things are actually a part of AI, and it's required to build a AI solution. One of the things which I missed out is hardware, the importance of hardware, right? A simple most of the time when you are just building a statistical model, hardware doesn't matter, because your laptop is good enough to build it. But when you're building a computer vision kind of model, to train the data, it requires tremendous GPU power, and these are expensive. Not only that, when you're using it live, you want the response time to be fast. You can't wait for 10-20 seconds for you send the image and to get the response. So again, the GPU, you need GPU even during the live environment. One of the examples I can give is, everybody would have gone to Airtel or Jio to open their account, a SIM. What happens? You go there, the guy takes the picture. First, actually, the sales guy takes his own picture. Then he takes your picture against some plain background. Then you have your identification like PAN, Aadhaar. He takes the picture. Then he asks you to wait for a couple of minutes, right? This process takes time. So generally what happens is, it takes your picture and it does a kind of a fraud detection. Are you taking a picture of a live person, or you are taking a picture of that guy? Same thing with the Aadhaar, like, are you taking the picture of the original Aadhaar, or you are taking picture of the color Xerox of that Aadhaar, this thing. So these things takes time. These are all image which goes to the centralized server. They run some AI model and they tell, okay, I think this is fine. Not only that, they match your photo or match your photo with the pic which is there in the Aadhaar and see whether it's matching. And if you are already existing customer, it will try to match your picture in your in their database also, along with other parameters. These are all this process takes a lot of time, and because computer vision is involved here, it's very computationally intensive. So when we say, okay, I want to build a AI solution, it's not always cheap, right? I mean, these GPUs are very expensive, and we need to think from that aspect also. And many times that becomes a big pain point, because in this case it's okay, we sit there wait for 1 or 2 minutes. In many cases it may not, right? So these are the things which we may have to consider.
Okay, Harish, thank you. That's a very interesting way of explaining what AI is, and it's been very interesting to know what are the various facets of AI. You talked about supervised learning, unsupervised learning. You talked about collecting data, about validating data, building some rules and coding it, and then using machine learning, how the computer itself learns how to find patterns and then take meaningful decisions. And a couple of good examples where you gave about autonomous self-driving cars and how it works and how AI forms core of it along with the various other parameters. Now I have a couple of questions for you, Harish. The first one I want to ask you is, there's so much of noise and talk about data privacy, not just in India, in the US, in Europe, in Australia and other places. So how real is it, the threat when it comes to data privacy and personal privacy?
It's a very valid threat actually. So you don't know how the companies are using the data, right? I mean, so that's the reason the European Union came up with their own GDPR, where actually they need to use they need to get the permission from the user to use a certain data. And right now we are going in the right direction, and it's very important. I'll just give you an example. 5-6 years back, I have this habit of going to meetups and all. In one such meetup, one of the startup, right, they were building some solution which helps in recruiting. So we are discussing, and he told they go through their LinkedIn profile, the social media profile, to understand whether this candidate is good. I was thinking, is it okay? At that time we may not have the legal framework which prevented this, but still deep down it's not ethical to go through their personal details and then you sell the solution to other HR firms saying that, okay, whether this guy is good or bad, right? So now I think most of the big companies, when they build a solution, they have this the data protection as their primary focus, and it's very important. And I'm worried about these startups who want to build this solution very fast, whether they are following it or not. And they would be forced to do that because many countries are coming up with their own policies forget usage, even where you store the user data also is a matter of concern. Like in India, they mandate that we have to store within India. So it's a very valid threat, and it breaches our privacy in many cases.
But Harish, on the one side, people don't want to pay for content or data, and at the same time, we are all dependent on data. As I said, you take your Google Maps, you take Google search engine, you take various social media platforms and portals, to the extent that somebody has written a book saying that internet is a second oxygen. Imagine if internet was shut down for, forget about a day, for a few hours, the world will almost come to a standstill. When that being the case, is this cry about data privacy and data really justified? Can you live without data?
See, we use Google, we use Facebook, and it's free. Nothing is free. Actually, your data itself is what you are paying them, right? So when you use Google or Facebook, we know already that they are using our data, right? And they take our permission also. When they might hide it somewhere, and so you have to go deep down their website to do some settings. But still, the question is, what about those companies which are using your data and you are not aware of it? That is the main concern. And right now we have this Aadhaar, PAN card, and all those things used everywhere, right? Is it protected? So those are. I'll tell you one thing. You go ahead and open a brokerage account, okay, and you use a mobile number which you just last week you got this mobile number. Within a month's time, we'll start getting calls. Sir, we are from PMS. Do you want our service? How they're getting the data? This is my real concern, right? We need to have stringent law. Somebody is selling data somewhere, right? You don't know. I'm not telling the brokerage firm is doing. They might be using some vendors for doing some management. In the black market, any data is available with a very nominal price. So how we prevent this, right? That is very important. But willingly you are going to Facebook and Google and you're sharing the data. I mean, it's at the end of the day, it's an individual choice. But without your knowledge, somebody using, that's not acceptable.
Right. So being responsible in the way in which we manage and share data is critical. Another interesting, based on what you talked about self-autonomous driving cars, and I know you worked on this project for some time. Do you think these autonomous cars will work in India? Can it work in the streets of Bangalore, Bombay? Or will it just be a standstill?
10 years back, right? 12 years back, when this Google Maps was used in US, same question came up, can we use Google Maps in India? We don't. Now see, everybody is using, right? I mean, I came from Udupi to Mangalore, I use Google Maps. But 12 years back, if somebody asked me, can I use Google Maps, I will say,
will it work in India?
Yeah, but in US it's working because the roles are pretty organized, but here it's working here also. So I have learned to say, not to predict something, right? You don't know how the technology, changes. I was seeing a YouTube video on that Mahindra's latest car, XUV 700.
700,
right?
yes.
I think they already have a lane change thing. I mean, they say it's working fine.
Anti-collision, braking, and lane changing.
Yeah, so they've started using it. This is how it starts, right? You start using it. As we learn from experience, right? AI learns from data. The data is the experience. So you collect more data. I think Mahindra will not stop here, right? They will collect the data. They will try to improve their model. So I think 10 years down the line, right? I feel still, as I told, I don't want to predict. It's possible, but I would never say, no, it's not possible. There's a probability that it can happen. Yeah.
That's great news for us, that we could have driverless cars and autonomous cars running on the streets of India. That's very good news, Harish. Good to know that. The last question before we wrap up, Harish, is there's a lot of talk about the computing power, you yourself said, increasing. and that there are a lot of movies and science fictions which have predicted that the computers can take over the world, right? So we are also talking about a supercomputer which can compute as good as your brain, right? So is it a threat? Do you think that one side people think that the computers are going to take over us and human beings will become slaves of these computers, whereas other people think it may not be, it's only there for the betterment of the humankind? What is your look at the future? Is it a threat or is it a
in ideal case
fiction?
Ideal case, it should be used for the betterment of humankind, as you mentioned. Let's assume for a moment that it's possible, right? It can take over. You think the government will allow it to happen? They will bring a lot of laws which prevents. Something is getting misused. Immediately they'll send a law, make a law to prevent its growth. Actual concern for me is in the military use case.
Military.
Yeah, right. So the thing is, for example, I have your picture. There is this drone technology and all, right? I feed your picture and I fit a gun. I'm just giving a science fiction, right? Let's go there. I give a picture, I give a location, it goes, shoots and comes back. Then, so these are the use case which is still possible, right? And how we can prevent it? That's we have to think, right? So, yeah, it's some aspect is a threat, but I think as AI taking over the world, I think it's still a science fiction.
It's still a science fiction. It's still a science fiction, not like Indiran or Robo the movie, right? So with that, Harish, it's very reassuring to know that the world is safe. AI is to be used for the betterment of mankind, and we don't foresee any foreseeable threat from the artificial intelligence technology, as long as industries follow good ethical practices and government have human-friendly policies. We have nothing to worry about, and we can look forward for some better days using AI. And thank you very much for
Thanks a lot.
explaining to us in a simple way how AI works for us. And thanks to all our viewers for subscribing to our show, and look forward to future episodes of People at Work. Thank you.
Thank you.